So in 9.5, the biggest thing you learn about there are the inscribed angles. So we were just talking about this. If you have a central angle, that's an angle whose vertex is on the center of the circle. If that is 50 degrees, then so is the arc. The arc is also 50 degrees. But then in section 9.5, we introduce the inscribed angle, which has its vertex on the edge of the circle. And its value would be half. So that would be a 25-degree angle. Okay? So we had learned that. We had also learned if you have more than one inscribed angle that has the same intercepted arc, they'd be equal to each other. So, for example, I'll just draw another one. If I had this inscribed angle, call it angle 1, and then I also had this inscribed angle, call it angle 2. Wouldn't angles 1 and 2 have to be equal to each other? Of course, because they're both half of this arc, whatever it is. So angles 1 and 2 would be the same. Another cool thing that we learned, but you could get there anyway, if you have an angle that is inscribed in a semicircle, it's got to be...
Why is 90 degrees? Why is angle 1 equal to angle 2?
Because they're both half of this arc.
Oh, I see.
Yep. Okay, so if we were to inscribe an angle in a semicircle, it would have to be a 90-degree angle, right? Because remember, a semicircle is half a circle, so this whole arc would be 180. That's not even there. So that's got to be half of 180 is 90. Avery? What's up?
Like, I know not in the near future, but on the final, would we ever need to use this stuff on
Oh, no.
Is there proofs on the final?
No. It's multiple choice. Let's see. What else did we learn? We also learned that if you inscribe a quadrilateral inside of a circle, any quadrilateral you like, just remember, inscribe means that you have to have all the vertices on the edge. Yes! Look at you go. Opposite angles are supplementary. So, I don't know what they are. Oh, I should mark that they're equal. But I know that angles 1 and 3 would add it to be 180. 2 and 4 would add it to be 180. Okay. And also, sort of in line with those inscribed angles, we had the chord tangent angle. So if I told you that this chord here was, I don't know. I know it looks like 180, but let's say it's not because there's my center. Let's make it 200 degrees. The measure of this angle right here would be equal to 100. It's still a half because this still has its vertex on the edge of the circle, right? So it's equal to half its arc. All right, and that's pretty much it for 9.5. Okay, 9.6. What did you have going on? Okay, so those are the cool angles like on the inside. So 9.6, we start talking about other angles in circles. So what happens when I have these two? Angle 1, for example. It's not a central angle, and it's not an inscribed angle. This is the one.
It's a chord angle.
Right, it is called the chord angle. It has two intercepted arcs, really. And to find the measure of angle 1, I add them together and take half. It's the average of those two angles. Remember that? And then we had angles that happen outside the circle. So if you had something outside, like maybe formed by two secants like this or something, how do you find the measure of angle 1 this time?
Half the difference of the two. In
That's it. So I still have these two intercepted arcs. I just want to take half their difference instead. So what you need to remember, guys, are you listening? If your angle is outside of the circle, you're taking the difference. If it's inside, you're taking the sum. And you always want half of whatever it is.
outside.
Yes.
What I'm confused on is like when it's inside, but it's not the angles that it's touching, like the highlighted ones.
So if you wanted one of these.
Yeah.
So you have some options. If I really wanted you to find angle 2, but I only gave you this, so say that was 80 and this was 70, who cares? What you could do is find angle 1, and then these two are just supplementary.
Okay.
So you could do it that way.
What confused me was like, I don't know, I did it a weird way. So
Oh.
that's how.
I mean, you could, if you had a way to know what that arc is and that arc is, you could find 2. But there'd have to be some way to get there. Yep.
Aren't for the first one, wouldn't the two angles, angle 1, would it be vertical?
Yeah, so 1 and 3 are going to be the same as each other.
So how come 80, like, how come it's 80 and 70?
Because they're not central angles. Right. Yep. No problem. And what? Who
They're
says?
vertical angles, but they're not the same.
No, the angles are the same, but the arcs are not.
Okay.
It does if you look at this diagram. Look at these ones. Right? There's no way those arcs are the same. Okay. And then you also have you could have a secant tangent angle. But it works the same way as this one does. So if your angle is on the outside, you're still doing the difference between the arcs. It's just that you would have this arc minus this arc. Right? It's always the big minus the little, take half. Big minus little, take half. And let's see. What?
The one with 180, right? Or like, or 180.
Yeah, so is that that's the tangent. Oh yeah, so you could have that too. So what if you had 2 tangents and I wanted you to find that measure? Same thing. Do the big arc minus the little arc, but it just so happens that in this one, that kind of makes up the whole circle, doesn't it? So I really only would have to give you one of the 2 arcs. So you would do big arc minus little arc, and then take half. So if I told you that this yellow arc was, I don't know, 40 degrees, I don't have to tell you anything else because you can find all the other pieces. What does the green arc have to be? It's got to be 320. So then angle 1 would be 320 minus 40, whatever half that is.
Isn't it like always 180 minus the little one?
Yep, you can do that too. So when you have tangent, you can also just, these two have to be supplementary. But even if you forget it, you can get there, right? 320 minus 40 is 280. Take half, you get 140 anyway. But it is kind of a cool shortcut if you recognize that you have tangent. Those two are supplementary. Okay, that's it for 9-6. And then 9-7. I love 9-7. Maybe that's just me. This 9-7 has to do with the lengths of things. So if I had 2 chords that intersected each other, so this has nothing to do with the angles now. Now I'm talking about the lengths of these chords. If this was 4 and this was 2 and this was X and this was 5, you can find the value of X by doing, you just multiply the pieces of each chord. So 4 times 2 equals X times 5. And then you just solve. So 8 equals 5x, divide by 5, 8/5. So if it's inside the circle, just multiply the pieces. Easy. If you have something like this, and now you have pieces of your segment that go outside the circle, your steps are the same. Let me see. Let's call this x, 3, 4, 5. Who cares? So if I want to solve for x here, does anybody remember what you do? Yep, go ahead.
Outside piece times the whole.
Yes, I do the outside piece, 3, times the whole thing, x plus 3. And I set that equal to the exact same thing on the other one. The outside piece times the whole thing, in that case, is just 9. And then just solve that equation.
If
If it's what?
If it's the inside piece times the whole thing?
Like this?
Like,
No,
no, like
she's
x
saying, like-
times x3 plus x, is it the same thing as 4 times
Oh,
9?
I don't think so.
Okay.
Yeah, outside piece times the whole thing. Outside piece times the whole thing. Which is the same thing I'm going to do here. It's just that the outside piece times the whole thing for that one happens to be the same. So I get x times x, or x squared, equals the outside piece, 3, times the whole thing, 5. And then just solve. And that's 9-7. Bingo bango.